Hi everyone, welcome to this tutorial. I'm going to go through unstructured data analysis using PySpark, RDD, and DataFrame. So guys, as you know that uh, there are always challenges about uh, how to go ahead with PySpark data structure, either RDD or DataFrame. In this tutorial, I'm going to take you into the unstructured data and let's see that how we can go ahead and then we can choose which one is going to provide better performance for us. So as usual on Google Colab, we need to install this PySpark. So it's going to install the latest release, and then we need to, import these libraries: Spark context and configuration for RDD purpose and Spark session for SQL and data frame purpose. All right, and then in one session we can have two driver. So one for Spark RDD and one for Spark data frame. All right. So and then we can run this. Okay, we need to firstly wait to get this done, and then we can load all required libraries. So then what we need here, we need to, on this tutorial, I'm going to go through my Google Drive because I have a log file there, and this log file is GHTorrent log file, and you know that this is really common data type log files because you can collect, you can collect data into a text format. And usually in this typical data, we have no pattern. All right, that's the reason we call them unstructured. And of course, and sometimes we can find pattern, and then if you can find pattern, uh, we can take them into the structured format because structured format is always faster than unstructured format for processing. So, all right, also is done. Let's go through this Google Drive to get connection. So it's going to get this connection to our Gmail account and give this permission. And then once you open this file, left-hand side, all right, so once it's mounted, and then once you refresh this, and the drive is here, right? Drive, and this is my OneDrive. Okay, if I sorry, my Google Drive. This is my Google Drive, and if you scroll it down, on your Google Drive. So guys, this file is available on the on the description of this video. All right, make sure to download it, and why not to store it on your Google Drive for faster access. So this is the file I want it. So what I have to do, I want to say copy path, all right, and it's done, right? You can close it. So loading data in RDD, I want to name it log RDD, all right, and then sc.text file, please read and paste this. All right, so and then paste it, and then let's take it into a partition. So guys, file is a compressed file, so it's really great idea to have data compressed because for loading it's going to be quicker, and Spark is able to read any type of data. But while you read data into RDD, then it's going to be get into the unzip format, and then the real size of data in this case is going to be about 1 gig data. So, and then let's say log RDD dot take. Let's take, the first 5 record, and then let's see what's going on. So, all right, so the first 5 record, we can see that this is first row, this is second row, all right, third row. So what the first step, we need to understand data. So the first one is info, comma. So it seems the first one, the first value is going to be the status of this, record. And then the date and time, or let's say timestamp. All right. It seems the downloader ID for GH torrent, and then 2 hyphen, and then few more information that you can see that, guys, that this part is completely unstructured. I mean, I'm talking about this one. All right, because first record, you can find something like this. After this ID, you can see that here we can find something else, because here we are closing this with this number, but here we are closing this line with exists message. All right. So after, you know, this 2 hyphen, we start with parent something, but here we started with added full red and so on. All right. So might be on these data, you can take these 1, 2, 3, the first 3 values into the structure format. It means you can use, let's say you can use regex. All right. And or maybe you can split these data because it's now on RDD. So you have 2 options, RDD or regex, to take out these 3 pieces of information and put them into the tabular format. And then, you know, like tabular format means you can easily get advantage of data frame optimization, query, SQLs, and many more information and optimizations that data frame can speed up your processing. But on this tutorial, we are not going to do so. We are going to take data completely unstructured, all right, and then load these unstructured data here once in RDD and once in DataFrame. All right, and then we can go through a bunch of tasks to see the differences in terms of the performance measurement on RDD and DataFrame. We expect to have RDD faster than DataFrame for unstructured data. So because RDD is, you know, is a low-level data structure, and it's going to read data row by row without consideration of any schema. But DataFrame, you know, for DataFrame, we would like to get data into the schema, which means to have attribute for the columns. So let's get it into the DataFrame mode. So if you want to do so, let's say that let's name it log a data frame. So first one, log RDD now DataFrame Spark dot read dot text. So guys, we have to work with Spark, which is the driver for DataFrame or Spark session, let's say. So where is it? The same path. All right. So here I do prefer, after reading, to also get advantage of repartitioning. All right, because for repartition, because for RDD we get it into 8 partitions, and why not to do like this? So, and then let's print it out. Let's say show truncate, be able to see, you know, the complete line, okay, without any problem. Otherwise, it's going to make a shorter version of the row if the row is longer. All right. So let's say N5 means 5 record, please. Okay. If you run this, so for both RDD and DataFrame, you can also consider caching or persistent. All right. And then you can get advantage of caching while processing your data in the parallel mode. But in this tutorial, we're going to consider both data structure in standalone mode without caching consideration here. So let's see. It seems, you know, because of this repartitioning, you can see that it takes time to get it into a partition. So perfect. So if you can see here, we have data frame. There is only one column, which is value. You can see that. All right. And all together is going to be here, but we have only one column. All right. So, yep, let's see. We want to go through this data on a structure that RDD read data line by line. This is really great here, right? We can go through these line by line, but data frame, guys, needs to go over the column firstly, and then take over each line. So let's do start, count the total number of log entries. So I want to use a time to get the performance measurement. I want to say the total count. Let's do firstly for log RDD dot count, okay, and then we can say like print this total count. Okay, so let me copy same thing and paste it here and then name it. Let's run this log RDD, and then for RDD we can change it to data frame and we can run it. So as I mentioned, we do expect to get better result for RDD, but for few small things, like for few actions like counts or sometimes take, it depends on data size and the parallelism you're applying on data. I mean, sometimes data frame provides better results, but if your data is small, not really huge data, if parallelism is wrong, means if you have the number of parallelism not as the expectation, this expectation usually comes from experience. So as I mentioned, like here, log file for count, okay, this is the action, a bit better than, RDD. All right. So it depends on, guys, as I mentioned, depends on the hardware, the parallelism, and the size of data, and the action like count here that you can see that for few things and very tiny operators, data frame can work better, because in this case still the concern is not about uh you know record by record uh, consideration, because it's going to count. It means that it's going to go through the log file, take each line one by one and count them. But here it means that take over the first column, the only available column, all right, and count it. Okay, so for task 2, filter log entries by log level. So what we have to do here, I want to name like info entries RDD. All right, so log RDD dot filter. All right, we have to filter lambda. So let's take line. All right, for each line, please get me those, those line that start with, info. All right, and of course here, let me know about debug, and then here start with debug. All right, so and then we can say print, let me use F format, number of info. Okay, and then I would say this, and number of debug. You can get advantage of this, and make sure to take time. And I want to copy everything. Make sure to run this. Okay. So okay, the problem here is, you can see that it was very quick, millisecond, because we forgot to add action. So guys, you know that transformation stage is lazy evaluation, not eager evaluation, and we need to use like count, okay, to put it into the action phase to make them execute, to make them into the execution phase. So count, we did here, right? Count, we expect data frame, as I mentioned, to get a bit better result. So let me run again. And here I want to say that not RDD, let's take it data frame. So, but for data frame, what we have to do for this filter is different. All right, we have to get the column. So if you want to work with the column, you will need to say from PySpark .sql.functions, we need to import column. All right, and then in the filter, I have to say that filter, go over the column. Which column? We have only one column, guys. Is this one, value, right? So let's say column value, please. And you can use like method, okay, like info and then the rest as it is. So also I can use the same idea and go through this and info. I want to say debug. All right. A number of info is going to be log. All right. And here it's going to be log. And then you can, oh, sorry, not log. It's going to be data frame. All right. And data frame. And there we go. You can run it. So, error, let's see what is the error. So from PySpark SQL function import, so info entries, log, oh, sorry, log data frame, log data frame. All right, so it took about minutes, right, to say that there are about more than 2 million record, including info. And my typo, you need to say info here. All right, and also number of debug. All right, is about, I mean, more than 7 million. Okay, it took 1 minute. You can rerun it. Okay, we can wait after this. So guys, as you can see that data frame 30 seconds. All right, because count, we found it out faster than data frame, sorry, faster than RDD. And here, a filter in data frame works weaker than filtering in RDD. All right, that's because of this filtering that we can go through. As I mentioned, in few cases, data frame can work much better. So, and it depends. Depends on the data size, the number of partitions, the resources you are taking over, like the number of cores, memories. These are all really important. Let's wait for RDD. All right, 50 says still about a minute. Okay, not big difference. So, all right, let's go with task 3. So extract the first 10 timestamp from each log file, log entry. Okay, let's take, time. And then here I have to say that timestamp. So RDD, log RDD dot map, lambda. So let's say line. What we have to say, we have to say line. That split firstly for us. All right. Why we have to split? Because I need this one. I need this timestamp. It means that we have to split the line. All right. Based on comma and then collect index 1 means second index. And then here we have to say that line split based on comma, and then please let me collect index 1, which is going to be second row. And that's it. And then timestamp dot take 10 record. So you can, run this, and then let's do with data frame. So in data frame, first of all, you need to import this split. All right, because we need a split function to be executed on partitions. All right, that's the reason you have to import this split. All right, from this function to make sure this split is going to be executed on parallel mode. All right, this split here is the function split, right? It's going to take over on each partition, and there is no parallelism on the split, because map is going to take this split to get run, into the parallel mode. So for second, right, for this one, and let's see how long take with data frame. So timestamp data frame, this log data frame, dot select. So what we have to select, you have to go through column, again, value. All right, you need to split it as we did in RDD. Split it. So based on comma, All right. And then you need to say, please return first index as we did. And why not to say, all right, alias, change the column name, let's say times town, something like this. And that's it, right? And then this one dot show n10. Let's run. So here we have mapping to be able to select, data based on this splitting. So then here we have to go through select, and then we need a split function from this PySpark library to do the same thing, guys, to split them. So if you notice, it takes longer, all right, compared to RDD. This is the sign that RDD is much faster for unstructured data while going through the selection and a few actions like splitting you want to do on data. The same output, but it took 50 seconds, guys. Is a lot comparing to 4 seconds. All right, let's drill it down. Let's go through task 4. In task 4, count the number of log entries for each log level. So log level was the first column. Let's say not first column. Let's say the first entry, this one. This one, right? Info, debug. So we have to count them, how many there are. All right. So still a split is there, right? You have to split it and take the first index. All right. Task 4, log level. Let's say count RDD. Please. Let's say count RDD. So log RDD dot map again because we need to say go over each line, and this line again split, and this time take me the first index. And why not to say count? There is a method count by value, and that's it, right? You can say print it out, and why not to use time? So I want to do the same thing with data frame now. So how to do with data frame? I have to say log level. So I want to use data frame now. So log data frame dot select again. I have to select, guys, I need to take over this one. Let me copy from here. All right. And come over here, log data frame. So split, but now we need index 0. All right, index 0. And this log level counts data frame dot group by. Make sure to group by because we need to count them. How? Based on this log level, let's say, we need to group by. How? Count. Okay, group by based on log level and count them because count is the aggregator, and then show. And here we go. You can run it. So guys, for data frame, as you notice, 36 seconds, we have about 2 million record starting with info, 7 million debug. So we have like means null value. We have E and IO error, right? These are the order of this counting. So how we did map, and this count by value, which is optimized method in RDD, right, is going to count. It seems it's like grouping by and aggregation. So what I did here, right, group by and aggregation, group by log value and aggregation based on count. So this count by value is going to do it in RDD. So guys, it seems you can see that it takes longer. So these are all let's say we can make conclusion that data frame is not the right choice for unstructured data unless you are able to grab some of those values that you can put them into the structure mode. and then yeah, and then you can take over data frame. Otherwise, a minute. All right, as compared here, guys, it's a big difference, right? 36 and data frame takes somehow twice. All right, take twice. Task 5. Let's make tasks, make them complex. So extract the commit information using regular expressions. Okay, perfect. This is really great task. So if we come back here, so it's asking this commit. It says whenever you see commit, all right, let us know the information. The information in this case is going to be this long one. So commit is here, the information, maybe the first one, I mean, not symbol, just first message. There is no commit, there is no commit, there is a commit, right? Means you can collect this one. All right, so how to do so? You need to write a regex. Okay, on unstructured data, how to collect information, regex is always the best choice. Make sure to import RE, which is the regex, and don't forget to use this time again. So commit pattern. First of all, we need to write a regex pattern. So regex, so we notice commit, we had two versions like lowercase c, uppercase c. So lowercase c for uppercase c, we are expecting, and then it's going to be exactly commit, starting with lowercase or uppercase c. And then we had \s means space, one space, or maybe you can say, I do expect to have one space or maximum 4 spaces, white spaces. Guys, I'm talking about, this one. White space, just one white space, just one white space. Maybe because it's a log, this is a big file, right? This log file is like really huge, about a gig file. So it's really difficult to load it and go through each line. Maybe you can take this one as the representation of the entire data. So why not to say we do expect to have, where is it? Yeah, to have like maybe 1 to 3 white spaces we do expect. And what else? And the rest is going to be this one, A to Z, lowercase, uppercase, and 0 to 9. These ones. How many? Plus. All right. So, and then what we can do out of these, right? Out of this, what we expect, I do expect to collect this one to know is it lowercase or uppercase. And also I need to get this one. You need to put them into the parentheses. Okay, it means that out of this pattern, collect this one and this one. Okay, because of the parentheses means we are going to grouping output. So commit, let's say commit RDD. It's going to be this log RDD dot flat map, because we want to get each data and each item separately. Lambda, so let's get line and then line, oh sorry, and then here re dot find all. Okay, we have to find all matches. Commit pattern. All right, this is the Python function on the line. Perfect. And what to do? Let's take 10 records. Okay. And then let's run. I want to do the same thing with data frame. So in data frame, so guys, you can see that. How is that quick? 4 seconds. These are exactly those messages in front of commit, and these are lowercase and uppercase of C. Okay, so it's very quick, 4 seconds. On data frame, regex, you need to import regex from library, from PySpark library. Okay, not Python library. Functions, import regex, extract, this one, regex p extract. So then I want to name it commit data frame. Please go over this log data frame. Let's select. So these regex P extract. So which column? Still, we have one column, right? Column value. So please apply that commit pattern. Commit pattern. So commit pattern is here, right? Commit pattern is here. And then you can specify which group you want to take. I just want to collect, this group means this is group 0 and this is group 1. Okay, means 0 and 1. I wish to say just 1 is enough in this case. So alias, and then let's name it commits. Let's say commit ID, and this commit data frame dot show and 10. If we do run, missing. So let me check what is missing here. So column. All right, I forgot to close it. Forgot to close. Okay, one more thing. Log select. Okay, regex p extract. So column value, commit pattern. So then alias. Okay, this one, guys. This one is problem. So I want to apply the same pattern on data frame. So sometimes these regex not working very well on data frame. All right, so let's see what's going on. So the first one, it took 4 seconds. All right, but here we do it. So I think we expect to get C, this C. All right, because of number 1. I think number 1 means this C. Let's see that. So let's see how long take. So obviously not really great output, right? We do expect to get, this like C, uppercase C, lowercase c, and so on. So 55 seconds, guys, is too much, right? Comparing to 4 seconds. Again, RDD, much better because the queries we are going to go through is not the attribute base, it's not the schema based attributes. Let's change it to 2 and run it. All right, so guys, you can see that the second output that we do expect to get, these ones, not really perfect. So guys, data frame, as you can see that, not able to work with regex. This is not really great, right? The output is not as we expect. Also, the timing is not as we expect. All right, task 6. So calculate the average length of log entries. It means we need to go through each record and calculate the average. So here I want to say that average of length RDD. So log RDD dot map. So because map, why map? Because we need to go through each line. I have to say line. All right. So the length of entry, sorry, the length of line. Okay, we can return it. So then here, after mapping, we can say reduce because we want to collect them to get the average. Or maybe because reduce here is the aggregator, is gonna to, you can add them all together So for instance, something like this, I want to say that like summation RDD, it's going to be this one. Okay, but dot reduce, let's say A and B, it's going to be A plus B. Lambda. You can take something like this, and then you have to say that average of RDD is going to be this summation RDD, all right, divided by the length, right? This one means this dot count. Guys, you can do something like this, but guys, again, count. This is, we know that in RDD, count takes longer than data frame. All right, in most cases, not all cases. So then this one, you can take it here, and why not to say time, and let's see what's going on. So why not to do it with, with data frame. So I want to say that average length data frame. I do expect you to select what to select again, the column. I mean the column value. All right. So I need you to get the length. So guys, you can in data frame. This is really great that I mean the methods are available in these functions, and then you can get them you can get them on the board like length. Okay, length, because then it's going to run it in parallel, the length of this column. This is what we did here, the length. All right, and then what we can do, let me double check, one open, and then all right, we can say that dot group by, and then we need to get the average. Okay, and make sure to collect it. So, and then if I say print this, and here we go with data frame. So guys, what we need to consider here, you can see that we went through, to get the length of each line as we did here, and then the radius to do the summation of all mapping, and then divided by the number of records. All right, and then here we do it with group by and average. And yeah, let's see. It takes 1 minute. So guys, always group by is very expensive operator, right? It's expensive operator based on time complexity. And if you can find a better way, it's much better to replace group by, all right, with some other solutions. And how long does it take? Let's see. All right, so 54 seconds, very close to minutes, just about 6 seconds, but still 6 seconds is a lot. All right, so as I mentioned, this is because of this count, because RDD count takes longer. So why not to say this one, to say just zero, the first index, and then again first index. So you can run this one again. All right, and then here also for this RDD, instead of doing all together, you might be using like this one. Okay, I'm going to say, or maybe you can use this for mapping, and then the average. That's it. This average is going to be this one. Okay, you can use either this three together or only this one. Okay, but why not in this case also name it average RDD to get the same output? So, but let me comment it that also you can make sure you can use one of these solutions. All right, since it's running, let's go through task 7. Find the longest log entry. All right, it's done exactly a minute. So about 6-7 seconds is 6 or 7 seconds is the difference. So task 7, the longest. So you have to name it longest. And 3 RDD is going to be log RDD dot. You can take advantage of max. All right, this is the method which is here. Find the maximum item in the RDD. All right, but how to use it? Can see that you need to provide a key. What is this key? The key can be a Python function. Why? Because I want to say that this key gets your main action. I mean, not the, let's say the main operation. So I want to say that go over each line. Okay, get the length of each line. And finally, get me the maximum. How to define it in the key parameter? We have to provide this Python function to say, all right, do it for me. Go through each line, get the length at the end, find the maximum. So time. Let's see how long does it take. All right. So what about data frame? So it's done 44 seconds to find the longest, the longest line. Okay, it says the longest line is this one. Okay, you can see that. So for data frame, I would say that longest entry data frame. Please go over log data frame. So we can order it, and then order in the descending order. So order by. So the length of this, column value. So guys, we did this length and column. We did them on top, right? We imported libraries. So please into the descending order for me, and then the first one. Okay, the first one and means index 0. And that's it. Okay, and let's take it over. So let's see how long does it take. This one took 44 seconds. Guys, please bear in mind that even if you're on the Google Colab, you might get this 44 like 32 seconds or maybe, 28 seconds. Everything really depends on these resources available for us. All right. So resources, CPU and memory, basically. So let's see how long does it take, and then we can conclude to how to go ahead for unstructured data. Great. So guys, 1 minute 10 seconds, more than RDD. All right, the same output, but the timing, the performance is different. So guys, if you want to wrap it up, so basically we found out count operator in DataFrame is much faster than RDD. Again, this one depends on data size and the number of partitioning and the resources. You need to consider these 3 stuff together. And second thing in DataFrame is filtering. Also filtering sometimes in DataFrame work faster than RDD. Again, it depends on the data size, the parallelism, and the resources that we have it for parallel processing. But let's say for the rest of actions, for the rest of operators, transformations, RDD is much faster than DataFrame. Thank you so much, everyone. Enjoy the rest of the day.